All right, the first part of the review is all the parent functions. So the first one is linear, which is f of x equals x, and a linear function is a straight line through the origin. The next one is the absolute value, which looks like a v. Absolute value. And you have the absolute value bars with the x on the inside. Then we have the quadratic, which is very similar. F of x equals x squared. All right. And then cubic. It's x cubed. And then we have two different types of radicals. We have an even radical. So an example of an even radical would be the square root, which would be an arrow to the right. And we have the odd radical, for example, a cube root, which would have the arrow to the right plus this extra thing, which makes it look like an S. So any odd number in this radical would be an odd radical. Any even number in this one would be even. And if there's no number, it's understood to be a 2. All right, the last three are all going to have asymptotes. So first we have rational, which has 2 asymptotes. One over x, exponential, any number to the x power. I just used 2 as an example. And log, which will be log x. Oops, you can't see that. All right, I want to go back in though and describe any kinds of symmetry that these guys have. So, linear graphs, they are going to be able to be rotated. They're going to be able to be folded a lot of different ways. So we are just going to say that this has both kinds of symmetry and leave it at that. We're not going to get any more descriptive just because there's so many different options. Absolute value and quadratic, though, both can be folded. So that's called reflectional symmetry. And they're going to be folded across the line x equals 0. Because they can be folded right here and it match up on both sides. And so same thing here, reflectional symmetry across x equals 0. Because if you folded it right here, it would match up on both sides. So those are the two that have specific reflectional symmetry. For rotational, there are 3 graphs that are going to have rotational symmetry that we want to be descriptive about. First one is the 2 that look like S's. So the cubic has rotational symmetry and the cube root. And if you rotate it about this middle point right here, that's where it would match up if you rotate it. So about 0, 0, about 0, 0. So the 2 ones that look like S's, and also the rational one. If you rotated the rational right here where your asymptotes match up, it would rotate. Are you retaking a quiz? Which one?
Wait, we should take a 400, right?
Uh-huh.
Probably the first 2 then.
Okay, let's start with the first one.
Yeah.
You're going to be on that video.
It's not going to bother you if I talk, is it? Okay. The three functions that have asymptotes are rational, exponential, and log. Rational has 2 asymptotes. Exponential has 1 horizontal asymptote, and log has 1 vertical asymptote. Right on the back. All right, this domain and range section here is going to be the longest. All right, so I'm going to do domain right here, range right here, and over here, domain, range, make some columns. And I want it in interval, set builder, and inequality. So the rational function looks like that. So I know for domain, I'm going left to negative infinity, right all the way to the asymptote boundary 0, and then 0 to infinity. In set builder, the only value I am not using is 0. And then inequality, negative infinity, less than x, less than 0, and 0 less than x, less than infinity. For the range, very similar. I'm going down for forever all the way up to the boundary 0, and then 0 all the way to infinity. And the only value I'm not using is 0, negative infinity, less than y, less than 0, and 0 less than y, less than infinity. The cubic function looks like that, which is using all of the numbers. You're going left forever, you're going right forever, because there's no boundary asymptote there that's stopping you. And then same thing for the range, you're going down and up forever. So negative infinity to infinity, x is using all the real numbers, and negative infinity less than x less than infinity. And then the range is going to be the same way, but with y's. Okay. For the line, same thing. You're going left forever and right forever, down forever and up forever. So your answers are the exact same as in part C. Negative infinity to infinity, all the real numbers, negative infinity less than x less than infinity, and range, same thing, but with the y's. All right. Quadratics I know look like u's. So your domain, you are going left and right forever because your u will eventually just go wider and wider. So the domain is going to be the same. You're going to use all the real numbers. But your range is different. You're only going down to this point right here. So your range is going down to 0, and it's a bracket because it's a point. For set builder, y is going to be greater than or equal to 0 because you're using the values above 0. And for the inequality, negative infinity less than y, less than or equal to 0. All right. X and y intercepts using the calculator. So clear your calculator out. And type your function in, 2x squared. So you can probably see on your graph that you are going to cross the x and the y at 0, 0. So I know here that my x-intercept is going to be 0, 0, and my y-intercept is going to be 0, 0. If you wanted to check, menu 6.1 will give you the x, and so it pops up here at 0, 0. Okay. Next function, 2 raised to the x plus 4. All right, so this one is never going to cross the x-axis. So I don't have an x-intercept. And the y, control T, go up to when x is 0, and 0, 5 is your y-axis. All right, last one. Log, there's no little number there, and so I'm going to put x minus 2 in there. And menu 6, analyze the 0. So your x is at negative 3, 0, and it doesn't cross the y, so none for the y. All right, max and min. So first I'm going to put my graph in, divide by x. And menu 6, we'll do minimum first, and then I'm going to type my interval in, -1 or -2, enter, 4, enter. And nothing pops up. So if nothing pops up, that's because your answer is infinity or negative infinity. And since I just tried to do the minimum, it's going to be negative infinity. Min is negative. Do the same thing for max. Analyze 3, -2, enter, 4, enter. And nothing pops up again, so your max is at infinity. X minus 1. Alright, so if you look, sometimes your points are already popped up if you don't clear your graph out, which is kind of just a shortcut. So you can see here your max, which is the higher point, is at 4, 3, or you can just put 3, and your min is at -2, -3. Okay, let's try the next one, 2x. Alright, max is the higher point. So max here is at 4, 8. Min here is at -2, -4. And press tab. Re-put in this one, -3x plus 4. Okay, on this one, I got my lowest value down here, so my min is at 4, -8, but my max isn't showing up, so I'm going to do it again. Maximum, -2, enter, 4, enter. And there it is now at -2, 10. Okay. When we're looking at the graph as a whole, you just have to look for the highest and the lowest point. So on this one, your maximum is at 3, your min is at negative infinity because it's going down forever. On this one, your min is at -2, your max is at infinity because it's going up forever. And on this one, be careful, your min is right here, that y value is 0, and your max is infinity. Alright, last problem, number 7. You are going to have one very similar to this on the test. So first, plot your points. 0, 5, 1, 6, 2, 5, 3, 3, 4, 0. So I have a ball, I'm standing on a building, and I'm throwing it in the air, and it goes up, and it comes back down. So that looks like a quadratic function. Okay? So part B is it's a quadratic function. Now part C says identify key attributes including symmetry. Well, we know that quadratics have reflectional symmetry, and this one has reflectional symmetry across this point right here, x equals 1. The intercepts, it crosses the y-axis at 0, 5. And it crosses the x-axis at 4, 0. Okay, and vertex is the very top point, which is 1, 6. All right, now it says relate their meaning in the problem situation. I think I said that wrong in the problem. The situation is not supposed to be there. So basically, I want to know is what's happening in this problem. Well, I know that the y-intercept is the height of the building. The vertex is how high the ball goes. And the x-intercept is when the ball hits the ground, because that is the arc of the ball.